Hello everyone. I'm gonna just share my screen here first and then we're gonna continue. Yes. Okay, so again, hello everyone. My name is Palo and I'm gonna talk about robust CI/CD pipelines. And let's get going. First things first, a bit about me. I'm an AWS community builder focusing on developer tooling. Also, I'm a lead technologist at Alma Media, and I've worked there for 10 years almost now. And I've been using serverless since 2016, and my programming languages of choice nowadays are TypeScript and Go. And there's a couple links if you wish to follow me, follow these topics more. Briefly about Alma Media, where I work. Alma Media is a publishing and digital services company with 50 or over 50 brands, focusing on news, entertainment, lifestyle, recruitment, data services, all sorts of stuff, marketplaces, and such. Some key numbers about Alma: we have 1,500 employees. The headquarters is in Helsinki, Finland, but we also have a lot of businesses in Eastern Central Europe. We started using AWS in around 2012 and started using serverless around 2016. And on that note, we have somewhere over 100 websites and apps. And one number that sort of tells how much we use serverless is that we have about 1 billion Lambda invocations per month. And as I said, we love serverless. Besides those 1 billion Lambda invocations, we have over 1 billion API gateway requests and almost 200 million AppSync requests. So we use AppSync GraphQL APIs as well. There are a couple links you might want to screenshot these. I'll try to put them in the chat after my presentation as well. But if you want to learn more about our serverless usage, there are a couple interesting links. I'm going to talk about how we can use infrastructure as code to help you with CI pipelines with serverless. And then I'm going to answer to these three questions, or at least try to answer to these three questions: that how to achieve faster development cycle, how to have more and better tests, and how to trick developers to do all that, because that actually benefits the CI/CD pipelines as well. And finally, how to deploy with confidence using multiple environments. But I'm going to start with the infrastructure as code. And in my team and in Alma Media in general, we use AWS CDK or Cloud Development Kit quite heavily. It's open source software where you can define your infrastructure using familiar programming languages such as TypeScript, JavaScript, Python, Java, .NET, or actually Go. Also nowadays, it shipped maybe a few months ago the Go support for CDK as well. But we use mostly the TypeScript variant of CDK. But this talk doesn't really focus on CDK, but it focuses on tooling where you use some kind of infrastructure as code tool chain. So it might be CDK, it might be Pulumi, it might be Terraform or something similar, or it might be the classic CloudFormation. But I really advocate using tools such as CDK where you're using real code to define your infrastructure. An example stack with CDK looks something like this. This is a TypeScript example which creates an SNS topic and DynamoDB table and Lambda functions, and then strings them together with required permissions and so forth. I'm not going to dive deeper into CDK. If you want to learn more, here's again a link to a deep dive which I've talked about CDK quite extensively. But the main point here is that we're using some kind of a tooling that's a bit more powerful than just writing, some YAML or JSON. So we're using a real programming language to define our infrastructure. Then how to achieve faster development cycles and how to have more and better tests and how to trick developers to do that all. because those are things that really help with CI/CD. The reason why I'm talking about those kind of things is that oftentimes I've seen that when there's a talk or presentation about CI/CD, it kind of starts from the assumption that we have already developed something, that we have some kind of a application already done, and now it's finished, and then at some later point we need to move it to CI/CD. We sort of have to put a stamp of DevOps on top of that. That's quite often what I see, and I think CI/CD is something that should be considered from the get-go. I'm not saying that I've personally always succeeded in that taking the CI/CD and putting it in from the right from the very beginning of a project, but that's something you should at least aim for. So this timeline is kind of the classic example. What many presentations, at least what I've seen, kind of assume that first some developers write code, and then developers are done writing code, and some later phase, some operations people are starting to plan the CI/CD pipelines, and then they implement the CI/CD pipelines. But this should be sort of concurrent process, so that it doesn't wait for the developers to finish. And also, in a perfect world, you have those DevOps teams where the same developers are responsible for defining those CI/CD pipelines. So it shouldn't be a separate process. One way of thinking is that you probably all seen this kind of a DevOps loop diagram. If you Google DevOps loop and put a Google image search, you're going to find like 100 different versions of this. But something like this, it's a loop where you sort of plan first, then you code something, you build it, you test it, you release it, you deploy it, you operate it, and then you monitor it, and so on it goes. And I think that one way to, or one really important way to improve these CI/CD setups and this DevOps loop is actually to start with this first part of the loop. Make this cycle faster and easier, and also what I mean with easier, it should be easier for your developers to work with this within this loop. So once this first part gets faster and easier, it also affects the second part. So this gets easier, and also you have a lot more opportunities there. For example, how you can improve the reliability of your deployments. So what could be the answer to this whole thing? Is this something mystical, magical thing that will solve all the problems? And is it some new fancy thing? Well, it's not the new fancy thing. It's not anything magical. It's just a test-driven development. So test-driven development is something that really helps you getting better at CI pipelines. And with test-driven development in this context, I do not mean that you have to always start with the failing test suite and then actually define the implementation. Of course, that is something you probably should aim at if you like that way of working. But with test-driven development in this context, or in this presentation, I'm really talking about something that you should focus your local development tool chain in such a way that tests are the main method of developing your application or whatever it is. So once tests are integral part of the local development experience, then you start having a lot of tests suddenly, and your CI/CD setup will be much more easier in some sense, because you're going to have a lot of tests already. You don't have to think about situations that how to make your CI setups more reliable, because you already have a good sort of premise there with a lot of tests. And let's dive a bit deeper into the testing. As I said, my team, we are using CDK, and a lot of teams in Alma are using CDK or the AWS Cloud Development Kit. And one thing that it comes with is this module called CDK Assert. And that's a testing sort of utility that comes with CDK. And it's actually based on this quite popular testing tool in Node.js world called Jest. And pretty much my idea is just all the things here. But you can achieve these similar goals with any modern tooling probably. So this isn't Jest specific, but I'm going to show some ideas and examples with Jest and CDK. So Jest is probably, at least my gut feeling is that maybe front-end developers know Jest a bit better because it's really popular in the React and Angular and Vue development world. But Jest is just testing framework that runs on Node.js, so it can test anything. It doesn't have to be anything related to front-end. And as I said, CDK uses Jest in the CDK assert. So if we are building infrastructure with Jest, why not use with CDK, and we have Jest there, so why not use Jest to test everything? That's my sort of thinking. So if we're talking about serverless projects, we're doing Lambda functions, or maybe we're doing Fargate containers or whatever, but we have some application code. So if we're writing Node.js-based application code, so we could test that with Jest. If we're writing CDK infrastructure with TypeScript, we can test that with Jest. Also, once we have deployed something, we can do end-to-end testing to our actual deployments or actual systems in the AWS cloud using Jest as well. And again, Jest is just an example. You can achieve similar results with any sort of testing framework and pairing it with AWS SDKs and things like that, other tooling. But of course, depending on the tool, your mileage may vary, but it should be doable with any modern technology stack. First of all, we should really focus on test TDD with our Lambda functions or our application code. So sort of traditional Lambda development locally has been, at least my experience is that quite a lot of people have done this in this manner, that they're doing this kind of console log-driven development, and they're running their Lambda functions with tools like SAM-CLE, local invoke, or LambCI, Docker Lambda, or something similar, where they're sort of emulating the Lambda environment and then executing the Lambda function locally. And that sort of leads to this quite slow loop where you modify your code, then you build your code, you execute it, and you see what's the output, and then you do it again and again and again. What I think is a bit better is to use, again, TDD with Lambda. So no matter what Lambda runtime you're using, use the testing tools that your programming language provides. So this could be, if I'd be doing Go Lambdas, I could use the Go testing utilities. But again, my team is using Node or writing Node.js Lambda functions, so we are using Jest here. And we're still writing unit tests for the inner functionality of the Lambda functions, that they have some smaller functions within them in the programming language itself. So we are testing those small units of code as well. But since we're aiming to do quite small Lambda functions, in that sense that we aim to do small specific Lambda functions instead of monolithic Lambda functions that do a lot of different things. So since we're doing, at least aiming to do a lot of small Lambda functions, we can actually easily test the input and output of the Lambda, the function handler. So that helps with the local development, that instead of invoking the function with your CLI with some tooling like SAM-CLI or something like that, instead of that, you just define test cases for your Lambda functions, and you just run the sort of the Lambda local execution as part of your testing setup. And the nice thing about using testing for your local Lambda development is that you can actually more easily test error scenarios. So often with the traditional method where you use some kind of a SAM-CLI where you locally execute your functions, you're often just testing the happy path, that what's going to happen if everything everything goes well. But you should also test things like, what if the database doesn't respond, or what if the data is corrupt and things like that. So with using proper testing tooling such as Jest, writing tests with Jest, that becomes quite easy. And you get this fast feedback loop because with Jest you can select a specific test case. So for example, if I have a test for this Lambda called my function, I can only run the tests related to that in watch mode. So always when I save my source code, the tests are going to run again and again and again. So I get this really fast feedback loop. So for a developer, that's a nice experience. And also they should really use the debugger as a side note that we live in 2021. So debugger is your friend, use it. But once you locally develop with these tests, you sort of need to think that how are you going to handle external resources such as third-party APIs or AWS services. So if you have an AWS SDK calling like Secrets Manager or DynamoDB or what have you, so you probably want to mock those services. There's a really great blog post by Matt Morgan about mocking AWS services with Jest and TypeScript. I really recommend you to read it. So take a screen capture of this, and I'll put a link in the chat after my presentation. But this really shows some great examples how to mock AWS services in Jest development. So you get this nice fast feedback loop where you're just testing your Lambda functionality, and you can also test things like what if the DynamoDB call fails, or what if the DynamoDB returns corrupted data, and so on and so forth. So it's a really, really nice way to test and develop Lambda functions locally. Then we get to the infrastructure part. This actually is something that starts to get really interesting. So let's think about infrastructure code and doing test-driven development with infrastructure code. Why would you do that? Let's consider a serverless application for a while. This is just something I made up. This doesn't necessarily make sense, but this has some few common patterns that you have some AppSync API that talks to Dynamo and Lambda functions, and then you have some SQS queues that talk to Lambda function, which again talks to Dynamo, and then you have event buses with DL queues and various rules that forward the events to, I don't know, SQS queues, Lambda functions, or state machines, or something like that. So where would you say is the business logic in this setup? Is it in your Lambda functions, or is it in the AWS services you're using? The answer is the whole infrastructure actually is your business logic. If you're doing serverless, and I really mean serverless, I'm not talking about just fast functions as a service, so just using Lambda. I mean, if you're really utilizing AWS serverless offerings, so you're using managed services such as EventBridge, event buses, SQS queues, SNS topics, S3 buckets, API gateways, AppSync APIs, what have you, DynamoDB and Aurora serverless and things like that. So if you're really doing serverless, then the whole infrastructure, how you define it, how you configure it, what kind of rules, for example, you have in your event buses, everything there is your kind of business logic. So the line between business logic and infrastructure gets really shady, or there isn't really a clear line there. So that's why you should really treat your infrastructure code as any other code. So don't think it's any way special. Think it as code. Think it as any other code. So if you're thinking it as a code, then you should definitely use good software development best practices there as you would in any other code as well. So you should at least have some kind of a linting, so static analysis there, and you should have some tests there. So again, in CDK, we can write these tests using the AWS CDK assert utility. And that allows you to make many different kind of tests. But here's a screenshot of one example test setup. This is some kind of a test that tests a stack that creates basically SQS queue for a dead letter queue functionality. So it tests that the DLQ stack creates an CloudWatch alarm related to that DLQ, and the DLQ has maximum retention period and things like that configured. The specific of this test doesn't really matter, but just the point that we're actually testing the infrastructure code we have written ourselves, because the infrastructure code can be what we have written. It can be quite complex in some cases, because we're leveraging all the AWS serverless offerings, and we are defining all sorts of logic related to them. So it's good to test actually what your infrastructure code does, so it fills the expectations you have. With CDK, with CDK Assert, you can do snapshot testing. You can do these fine-grained assertions, and also like validation tests to your code. And there's again a link to CDK documentation, which goes through this whole topic quite well. And I'll again post a link in the chat later. But just to note, this isn't anything CDK specific. You can achieve similar things with other tooling as well. I think something similar is possible with Pulumi as well, and something similar is possible with Terraform as well. I've done Terraform a few years back, but I haven't done this testing, so I can't really comment on that, but this is just some example I found that you can do this kind of unit testing Terraform code using Go or Golang as the programming language to run these tests. Then you should also lint, validate, and use some kind of a guardrails and other tools for your infrastructure code before you do your deployments. So couple popular tools are CFN Python lint and CFN NAG, which are both kind of tools that lint your CloudFormation output and check that you don't have any anti-patterns or bad practices used there. And these work against CloudFormation. So if you're using tools such as CDK, which basically outputs CloudFormation, you can put these, for example, the CFN lints, configure that to actually perform the linting against the CloudFormation generated by CDK. It might not be the most important thing to do, because you can do a lot of sort of CDK kind of handles a lot of things for you, and it aims to have sensible defaults and these kind of things. So the generated CloudFormation usually is quite good and well formatted or at least it doesn't contain these like bad anti-patterns. But of course, since you're doing it and we are all humans, we might make mistakes. So it might be a good idea to put some kind of a linting tool to the generated CloudFormation as well. Then you could do IAM policy linting. CDK again is great because it really helps you to define this like granular access control with IAM, and so it's really easy to avoid these bad practices. But again, you can define anything with CDK, so you might end up doing some anti-patterns there. So IAM Parliament by Dual Labs is something that analyzes IAM statements and checks that they don't have too wide permissions or incorrect syntax or things like that. I haven't yet paired this with CDK, but I think it's quite possible to have it somehow parse the CloudFormation and then get the IAM statements out of it and then pass those to IAM Parliament. But this is anyway a tool that you might want to take a look at, or some similar other tool to sort of control your IAM policies. Then this is an interesting tool, CFN Guardrails, where you have this simple set of rules that you can define yourself in this kind of a rule file, and then you can run your CloudFormation files against those guardrail rules. So it'll point out that if you don't have things like encryption enabled or something like that, whatever you configure there. So definitely check these kind of toolings. And again, as it works against CloudFormation, they work well with tools like CDK, which output CloudFormation. One CDK specific tool I'm thinking of really taking advantage this year is the CDK Aspects. CDK Aspects is just a functionality in CDK where you can sort of visit every CDK construct or basically you can check every resource that CDK creates. And while it's checking, you can do all sorts of things. You can modify the resource, or you can just check some values. The CDK documentation has this example where it checks that if the S3 bucket doesn't have versioning enabled, it's going to assign an error to that, and the CDK build step or synthesization step is going to fail then. And one thing I'm thinking about doing that I could do like a logic that for production environments enforces that for example, S3 buckets should have removal policies set to retain, and in development environments they should be set to destroy, or something like that. So CDK aspects are a bit of a hidden gem in CDK tooling. So if you're doing work with CDK, do check those out. Then finally, the final phase of testing is the end-to-end testing your infrastructure. Before the previous section was about basically unit testing your infrastructure code and then doing some linting and various other checks against those. But the last phase after your deployment should be doing some kind of end-to-end testing for your infrastructure, basically validating everything was deployed correctly. So often I've done things like having Postman collections for APIs, REST APIs, and sort of validating the API inner workings with Postman or Newman CLI or something like that. But nowadays, since working with really various types of serverless services, there isn't always just the service you're building might not be just an API. It might have some kind of it might have queues, it might have SNS topics, it might have event buses, it might have S3 buckets, DynamoDB tables, whatever, and all sorts of AWS native integrations. So how I've come to think about testing them is using, again, Jest as the testing runner, and then AWS SDK actually to perform various checks against the environment. So here's an example of test that first with AWS SDK, I'm going to send an event to an event bridge, event bus. After a while, I'm going to get an item from DynamoDB. I'm going to compare or verify that it matches the expectation that if I send the event that it somehow modifies the DynamoDB item. So I'm going to do some tests that the DynamoDB, the data persisted in DynamoDB matches what I'm expecting it to be. And finally, if I have some API serving the DynamoDB data or something like that, I'm going to use some kind of a HTTP client to actually query the API. And interestingly, since this was, in this example, this was a private API protected by an API key. I know there's better API authorization models than API keys, but this is just for an example. So it was protected by an API key. So I actually used the AWS SDK to fetch the API key that I'm using in the tests. So it's not hard-coded in anywhere to API key secret. Similar things you can, again, achieve with any test runner and any AWS SDK. So if you're using Java or Go or whatever is your language, you can, if there's an AWS SDK there and some test runner, you can achieve this as well with any stack. And one thing that CDK really helps with end-to-end tests is that if you have sort of a lot of dynamic values that you need in your tests, it becomes annoying if you need to sort of have some kind of configuration file up to date always that points to various resources that your tests need to test against. CDK helps there because if you're doing CDK deploy, you can pass this parameter --outputs--file and give it a path to a file where it will print JSON after the deployment with various outputs from your stacks. So you can use those CDK outputs as a reference in your end-to-end tests. So that helps if you have multiple environments or some kind of a dynamic values that you can know beforehand. So you don't need to do that much configuration or do some naming conventions or things like that. So you can just rely on the outputs of the CDK deployment. And one quick thing to note that even with infrastructure end-to-end tests, you should test also the unhappy paths. So I had an example one time that I was only testing that in this context that the send event and query API steps work, but at one point I had a misconfiguration that the API actually responded without the API key. Luckily, that was a development environment, so nothing critical was exposed to the internet. But the main thing is to always test also for the unhappy path. So what if there's an incorrect authentication, or what if there isn't any authentication at all, so that the API responds with correct responses in those cases. But I've been talking a lot of testing now, and what you probably seen this kind of testing pyramid a lot of times, or some kind of a variant of it. But sort of my key takeaway is that all these automatic testing and linting, these steps should be a part of everyday development process, and they should be easy for developers to set up in your project. So once they are part of the everyday development process, your CI setup, sort of CI/CD setup, is almost ready even before you start doing it. And finally, how to deploy with confidence using multiple environments. So often when in AWS environment, for example, in my company, we started early on with AWS, so there wasn't that many best practices around. So we might have these really large AWS accounts that have multiple resources in it. But the truth is not this simple that it's clear that those different products are really well organized. The truth is actually that the resources are quite scattered all over the place, and it's sometimes hard to understand what resource belongs to what product and so on, and an error in one product might affect other products in that same account. So it's good idea to organize your AWS environment a bit more. So first things I recommend is to move these different products or product families to different AWS accounts, so everything becomes a bit more clear. It might be a bit of a challenge when you're getting started, if you're not used to this multi-account management using AWS organizations and things like that. But it's definitely something that you should consider to do. Then even when there's a one product or product family per account, there's a chance that your different environments might affect each other. So you have some kind of bug in your dev environment. Let's say the worst case scenario that Lambda function has an infinite loop, so it eats up all the concurrency in your production environment as well. So now your production isn't working. So you really should think about putting production environment into a different account. So this is what I've been doing. I have two accounts, product account and dev account, and that way the production environment is completely isolated from the development work. But you might think, okay, do you mean only two environments? No, I mean that you have two accounts, but you can have multiple environments. You at least need two environments for this setup to make sense, but you can have multiple more. At least that's what my team is doing. We have these production and staging environments, but we also have these pre-production, pre-staging, and then we have these more dynamic preview environments as well in our accounts. And this is nice because when we're doing serverless, having multiple environments doesn't really cost that much. Oftentimes it's basically free of charge. Sometimes it might cost something, but it's usually, since serverless pricing is usually based on transactions, so your development environment shouldn't have that much traffic, so they're usually almost free or at least cheap. So that's why we aim to have a lot of different environments for different purposes. And our setup is that we might have some development environments for some initial setup. Then we use these preview environments that our CI triggers depending on the Git branch name and things like that. Once we have merged those preview branches to main branch in our GitHub setup, then it gets and then our CI starts to deploy the pre-staging environment, which is just sort of verifies that everything works in that dev account. And then after that deployment finishes, it will deploy to staging environment. Now, if we want to go, and this is always automatic, so once there's a commit to main branch, it'll automatically trigger the CI. So we have always the staging up to date in the staging environment, sort of reflecting what's on the main branch in Git. And once we want to do a production release, we do just this GitHub release, or in other words, we do this Semver tagged Git commit. So that triggers our CI to do this production release, which again deploys to this pre-production environment in our prod account. And if that succeeds, it goes to the production environment deployment later on. And now the whole sort of pipeline is kind of done. I'm going to skip this slide, but here's a complex graph for people who like complex graphs. You might want to take a screenshot of this if you want to sort of investigate this more. I'm not going to go through this now, but this sort of describes how we are doing branching and how those what kind of a Git practices we have, and how those how our Git flow, sort of Git workflow affects the deployment model we have. But the short version of this is that we use these preview branches which trigger these dynamic preview environments. And once we push the main branch, that deploys to staging environment. And when we create a release stack, that deploys to production environment. And I'm not going to show any, GitHub Actions code or Travis CI code or AWS code pipeline code, because those are specific to a specific product. And I think the overall picture is more important. That whatever you do, try to put some effort to your CI setup, that it's as fast as it can be. So what we're trying to do is trying to do a lot of things in parallel. So a lot of concurrent jobs. You can achieve this with GitHub Actions. You can achieve this with Travis CI build matrices. You can achieve this with AWS code pipeline. So have a lot of things in parallel. So it'll in the end, if you have a lot of testing, a lot of building, a lot of linting, all sorts of stuff, it'll be a bit. There will be an initial delay when the job, when a single job trigger or initiates, but overall it'll usually be faster than doing all those steps sequentially. So we try to do these all testing and things like this really concurrently there. Once we've done those, we are going to check that, okay, do we need to deploy to pre-production, or is it like a pre-environment deployment? Does it deploy to pre-staging or pre-production? If it does, then it deploys there, runs all the tests, and finally it deploys either to staging or production and runs tests after that. So deploy with confidence means that you shouldn't deploy to any environment unless all these pre-deploy steps are succeeded. So installation, building, linting, testing your application code, testing your infrastructure code, and so on. And after you've deployed, then you should have an end-to-end test. And since I was talking about multiple environments, that means that we can actually do the end-to-end testing in multiple phases. So this is just some example where we have like a production release triggered. It basically installs dependencies, does all the linting testing and building and stuff like that. And then it deploys the pre-production environment, which in sense is also like an indication that everything works if the pre-production deployment succeeds. And after that, there's end-to-end tests for pre-production. So we know that the pre-production environment works as intended, and then we deploy to production. We are quite confident it will work, and even so, we still run end-to-end tests after the production deployment as well. So using all these patterns that we are gonna use infrastructure as code, we're gonna write tests to those infrastructure code, what we've written ourselves. We're gonna lint it. we're going to really well test our application code, and then we're going to write some end-to-end tests. And all those tests should be the responsibility of the developer, that they are actually writing the tests for what they are building with. So once we have all those tests, it's quite easy to sort of put them together, and voila, we have a nice CI pipeline for our multi-environment supporting serverless application. So that's an overview of what I'm thinking about CI/CD for serverless applications in AWS, and that's about it. So thank you. Go and deploy with confidence. I think we have a few minutes for questions if there are any. So I'll be in the chat, and I'll be also pasting the links I had in the presentation there. Thank you. There are, well, let's see, there's a couple comments. Yeah, that's true. There's a comment from Raul Rodriguez. It looks like you're showing us a lot of what is available to ensure quality of your application deployments. That is all connected to resources needed to run your app. How about infrastructure only? Alarms, metrics, SNS topics available for multiple teams to use, WAFs, web ACL rules. Any insights on testing these, let's say, resources supporting the overall application system? Yeah, that's a good point that I didn't really cover. Well, first things first, I feel that all these sort of observability related resources in AWS that you're using, like CloudWatch alarms, metrics, SNS topics, maybe AWS chatbot, some CloudWatch dashboards, X-ray tracing, things like that. You should define those with your infrastructure as code tooling. So what I'm doing is I'm using CDK to define those as well. I'm in the midst of building some shared constructs that several projects can use, so they don't have to reinvent the wheel all the time. So that'll help if you're working in a team or in a company that you have a lot of different projects. So you might want to do this, like shared utilities or shared libraries that solve these problems for you. And the idea is that it should be easy to define these, alarms and dashboard and metrics and AWS chatbot and things like that in CDK. So they are part of kind of the deployment you do. And regarding testing those, I haven't done anything special. I only test the kind of the CDK code, sort of unit test that what defines those resources, such as CloudWatch alarms, and I sort of expect them to work once I've deployed them. So I don't know. It might be good idea to have some kind of testing. Okay, sometimes we do, of course, manually test those, that we intentionally create some kind of a error situation where some alarm will trigger, and we see that, okay, we do get the alarm and things like that. But we don't have any automated testing for those, let's say, alarms and things like that. That's something I'd really like to hear if someone has done anything like that, or I should probably investigate myself too. But really good comment. I'm gonna just paste the links. And finally, here's the blog post mocking AWS with Jest. So yeah, there should be all the links from my presentation, and I don't think there was any other questions. Thank you very much for the positive comments, and any feedback if you have, you can send me feedback at Aripalo. I'm gonna put it there, feedback.aripalo.com. If you have any feedback about the presentation or questions that you want to ask later, so you can reach me there or with Twitter or LinkedIn. It's Aripalo as well. But yeah, I guess that was it. So thank you very much for listening, and hope you got something interesting there. QA tab. There's any CDK alternative in Azure stack. I don't know about Azure. Sorry, Pulumi might be something that supports Azure. I'm not sure. Maybe Pulumi works with Azure. Maybe I'm not sure. But yeah, thanks for pointing it out. I didn't spot the QA. But yeah, thank you, and have a nice spring going forwards. Bye.